Hello and welcome back to SAS From Scratch. Welcome to episode 12. This week's episode, or this episode for that matter, is all about formats and informats, and then also the put and input functions. We have to start with some definitions before anything else. So, what is a format and what is an informat? A format specifies how variables should be printed. It decorates the output and does not change the underlying value. One of the simplest examples of that is if we have a particular number, say 1, 2, 3, 4, 5. Excuse me. If we have a particular number, say 1, 2, 3, 4, 5, and we want to have a dollar value format on that. So we would have a little dollar sign in the front, we might have some commas to separate the thousands, and we'll have a dot and 2 decimals for the cents. So that's the simplest way of thinking about it. It's a decoration on top of the underlying value. The in format has a little more gravitas, because that's a way of telling SAS how it should read, understand, and store a particular value. So, for example, if we have something that says, let's say we have in string format 01 April 2023. SAS doesn't understand what that is. It's a string just like any other. But we can tell SAS we want you to read in that string with the in format date 9, and we'll look at date 9 in a bit. But that way SAS knows that it is something it recognizes. It's something that it can convert from that string into a particular number that it recognizes. And then that's what it's going to end up storing as well in the data set or PDV, wherever we're working with that. That's where it's going to be stored. So the format is a decoration. The in format has a little bit more of a punch to it, in the sense that that's going to impact you down the line. Apologies. I should rather do these videos in the morning and not in the evening. So let's first of all talk about put. We don't want to confuse the put function with the put statement. So in episode 5, we looked at put log and we looked at put, and those two were statements that either wrote lines of text to the log or to the results tab, or it can become more complex than that. We can write it to a certain socket or an FTP location, doesn't matter. The put function is not the same thing as the put statement. If you haven't seen episode 5, please go and watch it. If you don't know how the put statement works, but the put function is different. We've got to make that very clear. So the put function converts numeric values to character values based on a format that we provide. And we'll see how that's different from just applying a format and decorating a value. Because what we're doing here is we are taking a format and permanently decorating it into a character variable. We'll look at examples. Our input function uses an in format to convert a character value to a numeric value. The character value is obviously in a format that's not easily understandable by SAS. SAS will try to do automatic conversions from character to numeric, and vice versa. I didn't put it in here, but it can. So if, for example, you have a variable, say the variable is called x, and you say x equals 3, and you put that in quotation marks, then you have the string 3 and not the number 3. Now if you take that and you say plus the number 5, SAS is going to convert that 3, which is a character, to an integer, add 5, and it's going to give you 8. It's going to do its best to do that where it can, but it can fail in certain places, and you'll have values that go missing, or you'll get notes or warnings in your log, and this is bad practice, and we've got to avoid that as far as possible. The control of whether or not something is character or numeric for a SAS programmer must lie with the SAS programmer. Likewise, if, for example, you've got a number, so you've got the number 5, and you try to concatenate it with a piece of text, SAS will try to convert that numeric 5 into a character and concatenate it with the piece of text. Again, bad practice. We shouldn't do this at all. Always explicitly convert into the format you know you're going to need. And if you see a note or a warning in the log that states that automatic conversion has happened, go and investigate it and determine whether that needs to be explicitly specified or whether there's another issue in your program. In some cases, automatic conversion will not even be attempted. So, for example, in a where statement, if you say where amount equals 1000, if amount is the variable amount is numeric and you pass character 1000 in quotes, it's not going to try and do that conversion. It's simply going to say the value was not found. This is another good reason why we shouldn't be relying on automatic conversion. We have to make sure it's in the format that is expected. Okay, I want to, before we look at these widths, I want to look at some basics of formats quickly. So I think we're going to jump to SAS Studio, and I've already taken the liberty of getting an episode 12.sas file up and running for us. And while we're at it, I'll worry about the libname later because we're going to be looking at the school.sas7b data set as well. So let's do some format examples. Let's do something like data format examples. And now please note we're busy with formats and not informats. As soon as we start looking at informats, I'll be very specific and I'll rename it to informat examples or whatever it might be. So let's take a couple of values. Let's start with var1, and let's say var1 is 12345.6789. Now let's run that, and we've got 123456789. If we look at this, we have a numeric type of length 8 with nothing applied on it. If we wanted that to be comma separated for the thousands, there's a format that we can apply onto var1. And if you've worked with the length statement before, if you've worked with I think the length statement is probably the most similar up to this point, because we're obviously only looking at formats now. But so the syntax that we're looking at here is to say, okay, well, format, variable name, and you can specify multiple variable names, and then you can apply a format to it. So you could, for example, do, okay, var2, var3, and you can then say comma 9.2, which will apply the comma 9.2 format, which is a built-in SAS format, to variables var1, var2, and var3. Since they don't exist at the moment, well, we can probably create them. It doesn't really matter. Let's be a little bit more original. So let's do something like that. And so if we apply this format to these variables, to all three of them, we will see that I really hate, there we go. I really hate when it doesn't just auto size these columns. I wonder if I can do this. Give me 1 second here. No, I'll leave it as such. I wanted to move the camera slightly, but it's just going to make a mess later on. So notice now that we've got a comma separator here. We've got 2 decimal places for our decimals, and if we just go back to the raw data, it was called 6789 after the decimal dot, and it got rounded to 68. 987.65, 245.87. Again, 2 spaces for the two places for the decimal numbers. And then if there's thousands, and we should probably put one, let's just put another one in here somewhere. Just so we can see that the comma separator is indeed applied there. Now I just want to stress again that the underlying value here is not touched. The underlying value in var1 is still 12345.6789. The way that it's printed and the way that it's being displayed to us is different, but the underlying value is not touched. The one thing that we will see is if we click on var 1, 2, and 3 here in the columns section on the left hand side, we will now see that there is a format that's been applied to them. Another example is for if we want to take this to dollars instead of a dollar format instead of just a comma format. And now is maybe a good time to talk about widths. So let's do the widths first. So you'll notice what we've got here is we've got the comma format. We've got a width of 9 and a decimal of 2. And what this means is we're reserving 9 spaces, 2 of which have to be for the decimal places, and 1 of which has to be for the decimal dot. So that already removes 3 spaces from our width of 9. That leaves us with 6, which means that for this item here, we know that we're going to have a comma in between. So let's do this properly. If we take this number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we say we're going to apply format comma 9.2, we know for a fact that we're going to have the decimal dot and 2 decimal places. So that's going to round 6, 7, 8, 9 to 6, 8. That leaves us with 6 other spaces. Now where the difference comes in here, because 1, 2, 3, 4, 5 is only 5 characters, but because we are adding this 1000 separator, this makes up the other 6 characters. And so if we go and count these 1, 2, 3, 4, 5, 6, 7, 8, 9. This, I do still have to get used to these Mac shortcuts. We will see that this is exactly 9 characters. That takes up all of the space for comma 9.2. So for this format to apply correctly, to look proper, and to just, you know, sometimes the format just will look off, or the rounding will be off, or you'll be missing commas or dollar signs, depending on your format, if you don't give it enough length to put everything it needs to in there. So if we know that this is 9 characters, if we are going to apply a dollar format to it instead of the comma format, I can already tell you that the output is going to look like this. And this is 10 characters. So if we wanted to apply, given that this is our longest number, and we know that our longest number needs 10 characters, we would have to, if we wanted to apply the dollar format, we would have to apply $10.2. And if we run this now, we'll see that we have, I'm just going to click this again so that it brings it into the side. We have $12,345.68, $9,987.65, $245.87. And so you can have it be shorter than the length you specify, but if you go over that format length, you'll start having some discrepancies and weird stuff happening. SAS sometimes gives you a warning, not always, not in my experience at least. Sometimes it'll just drop a comma, or it'll drop the dollar sign or something of that sort. If we look at the underlying properties, the length of the numeric variable is still length 8, which gives us 15 significant digits of precision. The format, however, is $10.2. Total length of 10, 2 spaces reserved for decimals, 1 space reserved for the dot, we've got a space reserved for the dollar sign, and we've got a space reserved for the comma as well, which leaves us 5 other digits to work with. And if we, for example, had numbers in the millions, we would have to make provision for more comma separators as well when we were thinking about the length. So that's how the lengths work. In terms of how formats are stated, they would usually be in the format, call it myvar, and then it would be either format width and a full stop, or it would be myvar2, and it'll be format with a width and then a dot. And these values for W and for D are going to be numbers, so something like 10.2 or simply 10. But that's what the format names look like. So whether it's dollar, whether it's comma, whether it's a date, they're either going to end with a dot, or it's going to be dot and a number for the number of decimal spaces that you're reserving. So that's the very basics of how formats work. And again, formats decorate. We're not talking about informats at the moment. So these are just decorating the underlying value. And so one way of thinking about that is you can still do stuff with this number. There's nothing that, even though you've got a format on it, you can still say var4 equals var1 times 2. And if I just need to take out the redundant or the extra bits. If we run this, var4 is simply a double of var1. Now, if we had something, so let's say var5 is equal to $1,234.68. If we had something like this, and we said var6 equals var5 times 2, and SAS will try and convert this, I expect it would fail. Correct. So if we had this, so please notice var1 and var5 look exactly the same. var1 is a numeric with a $, format on it. var5 is just a character of length 10. And so because SAS doesn't know how to interpret the $, the comma, and the full stop when it just appears in a character variable, it can't do anything when we say take this and times it by 2. It can do that with var1 because var1 is simply a number that has been decorated, that has been printed differently. But when we refer to var1, we're still getting this underlying value, and we're not getting that. So I hope that's clear. I'm going to bring this back to var1 only, because I don't want everything to just be about the $, values. I'm going to quickly skip back to the slides just to check. So I'm going to read through these and just make sure that what I said in the SAS Studio section actually corresponds to everything that's in here. So SAS formats have widths associated with them. The width of the format should be long enough to include all the integer digits, decimal point, and or separator commas. There could be multiple separator commas depending on the size of your number, and the decimal digits as well. If applicable, if you use something like the $ format, there's going to be a currency symbol, and you need to take that into account as well, because that whole thing with all the bits that's in there is what ultimately adds up to your length. If your format's not wide enough, rounding of values and loss of precision can occur. If your in format is not wide enough, you will lose precision in storage. So make sure you have enough space in your format and your in format, the width that they have there. SAS should write a note to the log if the above scenarios occur. It will say, for example, format something dot something, format $10.2 was not wide enough to contain all of the data, and as a result, truncation or rounding or whatever has occurred. If you see something like that, you know that that format needs to be wider to encapsulate all of the numbers that's in there. Okay, there's some rules for creating formats. They are pretty similar to the rules for creating variables. So, and it's also very similar to what we looked at for lengths when we were talking in episode 9, I believe. So they have to begin with a $ symbol if the format applies to character data. So you'll remember from a couple of, I'm just going to call this recap. In episode 9, for example, we did something where we said, okay, the length of the student name is $10. And we don't actually need that dot there. We can just do this. I have a bad habit of always putting the dot, but technically this is more correct. So length of student name is 10, and because student name is a character variable, we have to include the $. And it's the same if we wanted to apply a format that was a character format. So we don't just have to have a number and then decorate it with $signs and things that would technically require a string if we wanted to do that. Otherwise, we can start out with a character and decorate it with a character format as well. So we could, for example, have if we had colors, we could say, okay, well, format. I think the example in the prep guide was car colors, and so you would say, okay, format the color variable with the format car colors, end with a dot. Formats always end with a dot or a dot and a number if it's decimal places. And so what this would do is, for example, in the data set, it would say B for blue. So the format would say, okay, if you encounter the value B, you print blue, even though the underlying value still says B. If the underlying value is R, you print red, but the underlying value still stays R. So you can still do it on character variables as well. You would just have a $sign in front. If it's a number, a numeric variable that you're applying the format to, you'll leave out the $sign. A format must be a valid SAS name. So by that, make it characters. It can't end in a number, because if it ends in a number, what are you doing? You're going to confuse SAS. Is the number part of the name, or is it the width that you're specifying? So you can't let it end in a number. Just use normal text stuff. Can't remember if you can add underscores in there as well. Just go and check your prep guide if underscores are allowed, or even test it out and see if it's allowed. You cannot replace an existing SAS format, so you can't go and make your own $10.2. You can, but you'll have to call it something else, like my $10.2 or whatever you want. A format does not end in a period when specified in a value statement. What that means is when we go and create that format and we'll look at the syntax for that, we're not going to put the dot in. It's only when we call that format to be applied with a format statement that we put the dot. So when we create that format the very first time with a PROC format procedure and a value statement within that PROC, we're not going to end it with a dot. Numeric formats can be up to 32 characters long. Character formats can only be up to 31 characters long. Quirk of the language. Maybe they leave space for a flag or something to indicate that it's character, or maybe it's a string terminator, whatever it might be. 32 characters for numeric format names, 31 characters for character format names. This is how we create our own formats with PROC format. So you'll notice here in the syntax that we have a library name. In this case, it's called format lib, and it's mapped to a particular path. We've dealt with the libname statement in episode 3. We've used the libname statement almost every episode since when we're referring to source data. And then we plug that format library reference in here. And so we've got a PROC format statement here linked to this library reference. And within this, here where it says more SAS statements, you're going to put in these value keys. That has a format name and then maps a particular range or a particular value with a particular label that you want to decorate that value with. And you can have multiple of these value combinations within the same PROC format procedure. The only thing to keep in mind here is that SAS looks for formats in the work library. And if you create your formats in a different library, you should make it clear to SAS where it should go and look for these formats. So you would do that with an options. This is format search, FMT search, equals, and then within parentheses, all of the extra libraries that you want SAS to go and look for format. So if you have this format lib, without the A, format lib, you would put that in these parentheses so that SAS knows to go and look for the formats in that library. Before we move on to the exercise for the day, I want to go over a few more formats. The one thing that I quickly want to look at is just for dates and times, for example, because that's very important, and that's something that we'll talk about next episode as well, in episode 13. But if, for example, I create, and for this I'm going to use the MDY function. The MDY function is a built-in function in SAS, month, day, and year, which gives me a numeric date value. And so if I say, okay, give me the 4th month, the 3rd day of 2023, that's going to give me back the number of days. It's a pure number, an integer number, which is the number of days since the 1st of January 1960. That is the SAS date epoch or epoch. I've heard it pronounced both ways. Don't crucify me in the comments if you don't like my pronunciation. So the 1st of January 1960, that is day 0 for SAS. Day 1 is the 2nd of January 1960. Day 2 is the 3rd of January 1960, and so on and so forth. Excel, for example, does something similar. If you look at Unix time, Unix doesn't start in 1960. It starts, I believe, 1st of January 1970. But a lot of your date and time systems run on this concept of an epoch that's 0, and then minus values or positive values go earlier or later than that epoch value. So if I say var2 is MDY 3rd of April 2023, that is going to give me 23,103 days since the 1st of January 1960. 23,103 days. And the nice thing about this is we can keep that numeric value. And what I'm going to do, just to illustrate that, is I'm going to make var3 equal to var2. And you can see here that these two are exactly the same underlying value. Now I'm going to be applying a format, a different format to these two variables. So just to make it neater, I'm going to indent it a little bit, and I'm going to bring that semicolon down so that we have a nice little block of format statements. So that everything's not, you could write everything in one line, but it looks really ugly and unprofessional. So don't. var2, I'm going to use the built-in date9 format. For var3, I'm going to use the ISO 8601 format. And if I run this now, we see that var1 has the date9 format applied to it. Sorry, var2 has the date9 format applied to it, and it reads 3 April 2023. var3 has the IS 8601 DA format applied to it. So that's date only. If it's date and time, it would be DT. And you can see that var3 is rendered as 2023-4th month-3rd day. And the important thing here to remember is these are just the decorations for printing. They do not affect the underlying value. Likewise, if we had, let's just say 1, 2, 3, 4, 5, the time variables in SAS, if it's just the clock time that we're referring to, it's the number of seconds since midnight. Not attached to a particular day or anything, it's just if midnight is 0, how many seconds past midnight are you for the clock time. And so that can range, I think, from 0 to 86,400. And so if we just apply a time format, a time 5 format and these are all just built-in SAS formats, and you will learn them as you go along in your SAS journey. But if we apply this, and again the underlying value is 1, 2, 3, 4, 5, but 12,345 seconds after midnight gives you 3:25 in the morning. Underlying value still reads 1, 2, 3, 4, 5. So that's how formats work. Now, informats work a little bit differently. I'm going to delete the recap for the length. We've seen how that works. So if I say, let me say here for the in-format examples that we have 03 April 2023, and we have 2023 04 03. So we're doing the exact same thing that we did here with these two. And what did we say? How many days was the difference? I believe it was 23,000 something. If we use an in format to go back, so if we, because please note that this is now a character, these were numeric variables, these are character variables. So if we say var1 numeric, and we use the input function, which will read something which is character and make it numeric, we supply SAS with both that character value and the in format that it should use to read it, to understand what it is reading. So I look at this and I say, okay, I know that this date is given to me in a date9 format. So if I say input var1 with an in format, this is now the input function takes an in format as the formatting argument. Then what this is going to give me is the numeric equivalent of this character value given this format. So I'm telling SAS that you're getting something in date9 format. So if this is date9, what would the numeric equivalent be of that? And there's our value again of 23,103. So if you look at var1 here, it's a simple character variable. var2 as well is a simple character variable. I just need to go and import that as well. So let's see what happens if we don't specify the correct input format for var2. So we know that var2 is actually ISO 8601, and these two data sets are not linked. I could delete all of this and this would still work, because we're taking this character value and just converting it to numeric based on a specific format. Now we know that this value here is actually IS 8601 format. So let's see what happens when we provide the wrong format to SAS. It simply generates a missing, and in the log it says there's an invalid argument. The mathematical operation could not be performed at line 74, and if we check our log line 74, it's this one. If we go and now change that format to the correct one, which we know is 8601BA, SAS will be able to, should be able to understand it. Did I type something wrong? Oh, I typed 8610 instead of 8601. That explains it. SAS should be able to understand that these two are the same numeric value. 23,103 days since 1st of January 1960. Likewise, the put function allows us to take the underlying numeric variable and make it a character based on a specific format. So if we wanted to say var2 char equals, so recall again that var2, even though we use this function, it's simply going to give us that value of 23,000 something days since the 1st of January 1960. If we wanted a solid character value, however, we would use the put function, which converts numeric to character, and we would tell SAS, when you make this number a character, what format to almost permanently apply to it. So you would apply that format, and then you take that thing and snapshot it into a character value and put that in a different variable. So if we say var2 and we say date 9 and we run this again, sorry, I made a mistake here. This should say var2. We can see here that var2 char is the same as var2. If we go and look at the properties, however, var2 is numeric with a date 9 format applied to it, and var2 char is just a simple character value. We cannot use this for numeric operations. We can use this one for numeric operations because this is a number, this is not. So that's how you use put and input together with format and INFORMAT to be able to decorate variables or permanently take the numerics with the specified format to character. Alternatively, you can take a character variable and given a specified in format to read in that character, you can convert it to a number to help SAS understand what that character variable actually represents. I'm going to head back to the slides because I think we've covered formats, we've covered in formats, and we've covered put and input as well. We have talked about PROC format, but we're going to see it in practice now when we move to the exercise. So let's do that. So it's a very simple exercise for today because we're just trying to see how PROC format and formats libraries basically work. We're going to use the custom school data set, and we'll take a look at that just now. So that's a custom data set that I've developed, and we're going to create two formats. We're going to create a format on sex, and we're going to create a format on age. So if the sex column says F, we're going to print girl. If the sex column says M, we're going to print boy. And then the thing just to take note of here is that F and M are already character variables, and we're simply applying another character decoration on top of that, a character format on top of that. On age, we're going to be looking at several different age ranges, and PROC format supports that. So if the child is less than 7 years of age, we'll flag him or her as a toddler. If between 7 but less than 13, they'll be flagged as a child. If 13 but less than 19, they're a teenager, and 19 and up, they'll be flagged as adult. I don't know if there's actually adults in this data set. I make them from random numbers, but we'll see. So I'm going to make a little note here just for exercise 12.1. And then I just want to make a couple of notes here as well. Just say this is an in format, and this is a format. Okay, so that's the difference between format and in format. Formats go with puts and in formats go with inputs. Let's do exercise 12.1. So let's start with our data set, and we need to map that library. So libname ep12 and access is read-only. Okay, that is our library. Let's just run that and make sure it's fine. It is, and then I'm just going to bring this into a data class, run set class, and then let's run this, and we can take a look at our class data set. Sorry, it's not. I'm confusing it now. It's school. School. You can see the file is sitting there. Okay, so let's save this. We've got a bunch of students in the class running. So there's a girl with the letter A to M. The name starts A to M. There's a boy starting with A to starting with M. And they've all got different ages and so on. So we can see there's Ed, who's 20 years old and still around in the school. And there's Mike, who's 19 and still in school. So they need some remediary classes probably. And what we're going to do is, if this is M, it's going to print boy. If it's F, it's going to print girl. And then we're going to do those age groups like we talked about. So we're going to start by creating a PROC format. And we're going to specify that our library is EP12. And we're going to create a formats catalog in this folder here. And we'll look at how we recall the formats that are in there as well. So PROC format library is EP12. We're going to do that value statement like we saw. And now recall, when we create the format with this value statement, we do not put a dot at the end. When we apply the format in the data step or in a proc print or anything like that, we will be adding the dot at the end. So we know that we have M and F for the sex, and we know that that's a character. So we know that our format, let's call it boy girl, is going to be preceded with a $sign, because it's a format that is applied to a character variable. And so we are going to say if we have F for female, it should print girl, and if we have M, it should print boy. And note again that that's where the statement starts and that's where it ends, because there's the semicolon. So you could technically put this in one line as well. We don't, because it's not readable by a human. It's very machine readable, it's not human readable. And then the other thing we're going to look at now is age group. And note that age group is not preceded by a $, because age, just to remind you again, if we look at age here, it is a numeric variable, whereas sex is character. That's why it's got the little A in the icon. Age is 1, 2, 3 in the little icon here to show that it's numeric. So for the age groups, SAS allows us a couple of neat little tricks that we can use. So we know, for example, that less than 7 should be flagged as toddler. And so there's two keywords that we can use here, and that's high and low. So we can say that low up to, so that dash is basically 2. So from low to less than 7 is a toddler. And low can be 6, 5, 4, 3, 2. It can be missing, whatever it might be. It's just if it's now less than 7, it's flagged as a toddler. If the student is aged from 7 to less than 13, and I'm just tidying up the text here with some extra spaces to make it readable, then they are a child. If they are between 13 but less than 19, then they are a teenager. And if they are between 19 and the other neat keyword that we're going to learn about is high. So we've got low on the lower end and we've got high on the higher end. So if they're older, if they're 19 or older, we're simply going to flag them as being an adult. The other thing that we know about these ages is that we have them as integers. So we could have technically just done something like this as well. But what I'm trying to show here is that you can use these mathematical operators less than 7, less than 13, less than 19 to in your formats, and SAS will understand them. So let's run this and just create these formats. Okay, where did I go wrong? Write access write access is denied because we made it read only. Let's just take that out so that we have write access to this library, and then we can run the PROC format again. And this time it should work. Okay, if we look at our log, we can see that format boy girl has been successfully written, and format age group has been successfully written to ep12.formats. And there's a format.sas7bcat file sitting there. So sas7bdat is your dataset format. bcat is your catalogs format. So that's where stuff like your formats catalogs will be stored. So now that we've got our formats, we need to apply them. So it's as simple as running a format statement. So we can say format the sex column will now get the boy girl format, and note that here we add the dot. Here the dot is not added. Here the dot is added. That was in the slides as well earlier. Age group is applied to the age variable. Note the dollar because sex is a character variable. Age group, there's a lack of a dollar because age is a numeric variable. If we run this, it should not work. It did not work. And if we go and look at our log, it will tell us the format boy girl was not found or could not be loaded, and format age group was not found or could not be loaded. So the other thing that we said in the slides, excuse me, the other thing that we said in the slides, I'm just going to go back up, is that SAS by default will go look in the work library for formats, but we can also specify other libraries with options format search. So we need to do that before SAS will be able to find these formats that we've defined, because we've not stored them in the work library, we've stored them in this EP12 library, which is linked to this folder. So if we say options format search equals, and then let's just say go look in work and go look in EP12, and we separate them with a space. If we run this again, it should work. It does. We've got Abe is a boy, Annie is a girl, Betty's a girl, Bob is a boy, Charlie's a boy, Cornelia is a girl, etc. Child, toddler, teenager. We saw Ed was 20 years old. He's flagged as an adult, and Mike we knew was 19. He's also flagged as an adult. So again, our underlying values here have not changed. So we can still do something like say double age equals age times 2. And if we run that, we can see this child was 12, double his age is 24. This girl was 3, double her age is 6, etc. So that underlying value we can still work with, but we've now got a much nicer way of looking at these values. That is pretty much it for the exercise. Always remember, you can maybe go and try this for yourself as well, something similar. If you look at sashelp.class, we have a bunch of names. So this is a built-in data set. We've got a bunch of names. We've got sex, male, female. We've got an age here. We've even got height and weight. So you could always do something here that says, okay, well, if you're over a certain height, I believe this height is given in inches, and the weight is given in pounds. Maybe you're tall, maybe you're average, maybe you're on the shorter side. You can always apply a format like this to the height column, for example. And note here that we've got decimal values. So that trick of being able to say less than a certain value is going to come in a lot more useful. So if you would not be able to just say 50 to 59 and 60 to 69, because then 59.8 would not be captured in the format. So you would have to say 52 less than 60, and then in the next line 60 to less than 70 or something like that, so that you get these little decimals in between 59 and 60 as well, for example. So that's basically it for the formats. We've now covered formats and informats. We've covered put and input. We've done a little exercise, and you can go and do something similar using the sashelp.class data set as well. That wraps it up for episode 12. This is kind of more of the if you're talking about formats and informats and put and input, you're getting more to the stuff that makes SAS, because that's not something you're going to see really in another language. Next episode, we're going to look a little bit more at the way that SAS handles dates, times, and date times, as well as some of the built-in formats that go along with them. So SAS has a bunch of formats built in, and you'll get used to them, and you'll start learning them and remembering them as you work with SAS. You should know a couple of basics for the SAS base exam, for example. But we're going to sort of fit what we've learned today about formats and informats in with how SAS handles dates, times, and date times. So a date is obviously just 3 April 2023. Time is just the clock time, so 10 past 1 in the afternoon. And in a date time, the way that SAS represents this is where date is the number of days since 1 January 1960. The date time is the number of seconds since 1 January 1960. For Unix time, it's the number of seconds since 1 January 1970. So SAS and Unix time are pretty similar, but there's a difference of 10 years there. SAS having its epoch in 1960 instead of 1970. So we're going to be looking at that. We're going to be very quickly talking about a couple of extra formats for dates and times and date times, but it's going to be a very quick episode. I think it's probably going to be the shortest episode that we do in this series, and likewise the chapter in the prep guide as well is fairly short. That's it for episode 12. Thank you as always very much for joining me. Appreciate your company on this. Feel free to like. You're welcome to subscribe if you want to see the next episode in your YouTube inbox. And as always, you're welcome to leave a comment to let me know where I can improve, or if I've made a mistake somewhere, which I probably have. But that's it for today. So until next time, have a good evening. Cheers. Bye-bye.